So we've got Natalya Zavina-James is joining
Great.
us.
Oh, don't forget as well, if you've got questions for Tim Peake about being an astronaut or anything like that, spacey kind of things, get them in. I've got my iPad.
10. It's very soon.
Yes.
But Natalya, thank you for joining us. So Natalya is here from the UK Space Agency, which is at the heart of all UK efforts to explore and benefit from space. Hi Natalya, how's it going?
Hi, good morning. Sorry, I hope you can hear me okay. My voice isn't too croaky. I'm good.
You've got a slight coffee cold, but that's okay. We can hear you loud and clear.
Fantastic.
Good.
Great. Well, we shall leave it to you, but thank you for joining us from Thursday.
Thank you very much. Right, I'm just going to share some slides, so bear with me. Let me know when you can see them, because I think it takes a bit of time with this connection, unfortunately. Fantastic. Okay, I will get going. So, I'm Zavina-James. I'm the Exploration Science Manager at the UK Space Agency. And this basically means that I get to look after the science that we send up to space and make sure that UK scientists have leading roles in current and future exploration missions. So, first of all, what is the UK Space Agency? Well, we started in 2010 with the aim to catalyse investment. So this means to support projects that drive money into UK space activities, deliver missions and capabilities that meet public needs and advance our understanding of the universe, and champion the power of space to inspire people, offer greener solutions to problems, and support a sustainable future for humanity. As part of this, we have a world-class expertise in space science, technology, and business. We have a loud voice with the European Space Agency and other institutions around the world, like NASA. And we have a track record of delivering programs that have propelled British technology to other planets and realized huge, huge innovations. And really the message we want to get across is that space is for everyone. But now I think focusing a bit more on space exploration, why even travel to space? Well, space is amazing. Space science and research also supports discoveries that improve our lives back on Earth. Studying other planets helps us to understand the origins of the universe, how the Earth formed, and what its future might be. It helps us to understand what's happening in space and helps us to understand the impact. So space weather can cause really big problems if we have a solar storm. It can take out power lines, it could knock out a lot of our modern technology, and space exploration helps us understand how we can stop this from causing major problems back on Earth. And scientists from the UK and across the world have run over 3,000 experiments on the International Space Station, from studying how plants grow in space to understanding its effect on our immune system and helping us develop better drugs back on Earth. So moving on, the UK Space Agency spends a lot of time thinking about discovery and how the UK and British scientists can play a big role in missions to space. UK scientists and engineers are part of today's most exciting space missions. They have helped us to send spacecraft to study the Sun and Mercury. They've built rovers to explore Mars, run experiments on the International Space Station, and have provided science and instruments that measure things to the most powerful telescope ever launched into space. That's the James Webb Space Telescope. But coming back to space exploration, which is the area that I work in, when we talk about space exploration, we talk about exploring the places that humans may one day live and work. So for now, this means exploring low Earth orbit, mainly on the International Space Station. We send science experiments and technology up to the space station. There, astronauts do the experiments for the scientists back on Earth. This can be things like understanding how spending a lot of time in microgravity, so that's where we don't have any gravity acting on our body, which is a lot of space, can affect your muscles and skeleton. If we want to send astronauts on long missions to Mars and maybe even beyond, we need to know how their bodies will be affected by spending a lot of time away from Earth and in an environment with weightlessness. So lots of experiments focus on understanding how the human body adapts to the space environment. And this research can also help us to understand the aging process back on Earth. And I think Orson talked a bit about that just before me. Moving away from low Earth orbit and forwards to the moon, we are involved in Artemis. Artemis is NASA's new lunar exploration program, which includes sending the first woman and the first person of color to the moon. Through the Artemis mission, NASA will use technology to study the moon in new and better ways and prepare for human missions to Mars. So it's going to be looking for water on the moon and working out how to best use it. It will be studying the moon to discover all of its mysteries, and we'll be using this mission to learn how to live and work on the surface of another celestial body where astronauts are just 3 days from home. We'll also use it to test the technologies we need before sending astronauts on missions to Mars, which can take up to 3 years. And so we're really super excited to see what UK science ends up happening on these missions. It's still a bit away. But moving on from the moon to why we're all here today, to look at Mars. We really, really, really want to put humans on Mars. I think Orson also talked about this. But before we can do that, we need to know just as much as possible about it. Has life ever existed there? Does life exist there now? What form does this life take if it does exist or if it did exist? What are the dangers to future human explorers, and what are the dangers that future human explorers could potentially impart onto any life that might be there? And finally, how easy is it to live and work on Mars? So the UK Space Agency is working with the European Space Agency to launch the ExoMars Rosalind Franklin rover in 2028, and I think there is a video that can be played to show you a bit more about this mission. Thank you very much. Really, really exciting, right? So this part of the ExoMars mission is actually the second half. In the first part, we sent probes to orbit Mars to understand more about its atmosphere. But now we really want to learn about its geosphere. So that's its rocky surface and anything that might be underneath. So the really cool thing about this rover is the drill that it will use. Previous missions to Mars that have sent rovers to land have focused on looking at surface samples. So that's things just at the surface. But Mars's surface is exposed to loads of radiation, and so it's quite hard to find signs of life because the radiation just obliterates it. But this rover can drill really deep underground to find fresh rocks that might have better preserved the evidence of life or existing life. So this rover really is the first of its kind to combine the capability to just roam around Mars and to study its depth too. We know that the red planet has hosted water in the past, but it has a dry surface today that's exposed to this harsh radiation. But this rover is really going to do what none have ever done before and really target to look for evidence of past or current life. And the way we do this, or the way we know how to do this, is actually by studying the rocks on Earth too. And so a lot of geologists end up working on projects like this. And as a geologist by training, I think this is just the coolest thing. But back to Mars, the rover is going to land on an area called Oxyoplanum, which contains one of the largest exposures of rocks on Mars that are around 3.9 billion years old. But what's really special about the rocks here is that we know that they are clay rich. They're full of minerals that you find in clay, which indicate that water once played a significant role here. There could have been several different periods in this area where conditions at the surface would have been habitable by life. There could have been large rivers stretching at least 70 kilometers long and maybe 600 meters wide, which formed from 4 distinct catchment areas and would have meandered through the flat Oxyoplanum. And so we really think this is the best place to land if we want to search for life, which is what we're trying to do on this mission. But when the rover lands, it's going to need to see where it's going. And UK scientists have been working really, really hard to develop eyes for the rover. And the eyes are called PanCam, and they sit on top, kind of branched out right there. So in this picture, you can see at the top, we have PanCam, which it's panoramic. So it will allow the camera to see what's going on the surface of Mars, all around it. And it can tell us a lot of things about things like rock texture, grain size, and colour. And these are all really important features that allow scientists to figure out what the rock is made of and how it formed. And like I said, we have a lot of geologists working on this. Understanding the rock you're looking at is so important when you're looking for signs of old life. And it's not always a fossil that you're going to find, like a nice little spiral. Sometimes it's just a grain that's slightly different, or a slightly different colour, or a type of mineral that can only be produced by bacteria. Now, in this video, which hopefully plays, you can see how PanCam sees. So hopefully there you saw how it could get really close to the rocks. It could like take in the bigger picture as well as going into the detail. But maybe you noticed something else about what it's looking at. And maybe, in fact, you've noticed something about all of the pictures of Mars that you've seen, which is that it's very orange. So Mars is covered in a very thin layer of iron-rich dust, which makes everything look a bit orange or brown or red, especially to cameras. So this can make it quite hard to choose rocks that have the minerals that could indicate life or previous life. So in order for the Rosalind Franklin rover to sample the geological formations that are most likely to have the evidence we look for, we need this two-stage approach where first of all we have this big powerful camera that can take these wide-angle images and these really high-resolution pictures of the rocks so we can determine shape and texture of the target. But it also needs something under its eyes, which is called an infrared spectrometer, which we can use to then zap the rock. And then when we zap the rock, we can learn more about the bulk mineralogy. So that's all of the kind of the different chemicals that rock is made from, to make sure that we are drilling a rock that contains minerals of interest, because otherwise it could just be sand. And that spectrometer That instrument is called ENVIS, which is Welsh for rainbow. It uses infrared, so that's the same kind of wavelength that your remote control uses, to identify the best rocks for Rosalind Franklin to sample to find the things we are looking for. So it really is a second pair of super eyes that go under the eyes of the rover. And both of these instruments have been developed in the UK by really clever UK scientists, which is great. But moving on from Rosalind Franklin, what's next for Mars exploration? Well, we're really excited about Mars sample return. So I've just talked about a rover that's going to do some really cool analyses of rocks on the surface of Mars. But what's the next best thing? Apart from sending humans to Mars to look at those rocks, it's bringing those rocks back to Earth. So the Mars sample return mission, it has been proposed by NASA to return samples from the surface of Mars to Earth. The mission will use robots and rockets to collect and send samples of Martian rocks, soil, and the atmosphere to Earth for detailed chemical and physical analyses. And the mission is being planned jointly with the European Space Agency, and it's something that the UK Space Agency are hoping to get involved in. And who knows, maybe even some of you will end up working on the samples when they come back. But I'll leave it there, I think. Thank you very much for listening to me. I'm happy to take any questions.
It's good that you're ready for questions for you.
We've got 30,000 questions for you, so I hope you're ready. I hope you're comfortable and are ready for all of these. Okay, well, let's start here. Aylesbury Grammar School want to know, I think this is a great question, you're perfect to answer this. How will we get water, as all the water on Mars was either frozen and dirty or evaporated? Many thanks from Aylesbury Grammar School. So we talk about water on the moon, but how do we actually get it into drinkable or usable water?
It's a really great question, and it's something that that scientists are currently working on. There are some really interesting ways of extracting water and then purifying it by bubbling plasma through it, for example. That's some really exciting research that's going on. It's still a very active area of research. It can involve melting, and yeah, a lot of plasma seems to be used. I think it's everyone's
plasma,
favorite.
in inverted commas. Yeah, insert plasma. Actually, would the idea be, like, for example, if humans are going to be going to Mars, would we send like all the kit to make water kind of ahead of the game, as it were? So when we arrive, it's all ready there. Is that the sort of idea?
I really don't know. We honestly aren't allowed to think that far ahead at the moment.
I thought
We're still trying to get a robot.
Okay, we've got to start with the robots and then we're getting
Well, I'll tell you what, Aylesbury Grammar School, if you've got some good ideas about how to make water on Mars, get in touch with ESA.
Queensmead School in Islip, they say, if we visit Mars one day, when will we be able to grow crops on the Martian surface? Will it be impossible, or can we terraform to support plant life? So terraforming, transforming the planet. And
that is a fantastic question. I think that it's possible, and I remember when I was back at university, a professor doing some demonstrations of growing things on a kind of a pretend Martian soil. There's a lot of iron, so it could be quite nutrient rich. I think we definitely have to take things with us, certain fertilizers, and we would have to work out how to deal with that radiation problem. But I think if we can tackle the radiation, which we'll need to do anyway to send humans there, then it's got light, it's got some oxygen, it's got everything plants need, in theory.
I wonder if it's, I mean, could we genetically modify crops that are more resistant to radiation, for example?
Definitely. I think that's something that people are currently studying on the ISS too, in fact. So it really shows how the work happening on the ISS, the International Space Station, is feeding through to exploration to the moon and Mars.
It's a good point. Note to self, bring fertilizer.
Yes, I mean, it's going to be very heavy. There's a lot to pack into that rocket.
There is. Although I seem to remember, didn't what's his name in The Martian, didn't he grow in his own poo?
He grew potatoes, I mean, take notes maybe?
Yeah, I don't know if I want to eat that. Actually, this is a question. It was about the atmosphere. Surish, I'm not sure where Surish is from, but would like to know, what is the atmosphere like on Mars?
That's a really great question that I don't know off the top of my head. It's got a lot of carbon dioxide and nitrogen in it.
Yeah.
It's quite a lot different to Earth's atmosphere.
It's a lot thinner than the Earth atmosphere as well. It's like being in a kind of rarefied upper atmosphere on Earth, I suppose, where it's very, very, very thin.
Yeah. And Furnace Academy wants to know, does Mars have its own seasons like we do on Earth?
Kind of. And if Orson's listening, he may be putting his head in his hands. But I think Orson mentioned that there are only certain times we can even launch missions to Mars, because it might not have beautiful springs and summers and autumns and winters, but it does have a lot of dust storm seasons. And studying Mars weather for future exploration is a really exciting area of research that's currently growing in the UK to understand how Mars's seasons, which mainly focus on lots of dust, or not very much dust, how they can impact future missions.
Yeah, because I mean, there's such an issue, isn't it? If you've got loads of dust flying around, and if that gets into rovers as well, like, you've got to be really considerate of that, haven't you? I mean, it can cause problems.
Yeah, I was really amazed, actually, if you look at the kind of close-up pictures of the rovers, just how much damage is done to things like the wheels. Obviously, the solar panels on some of the earlier rovers are all covered in dust, so they don't work anymore. It seems to be quite a difficult place to live and work. And there's no Premier Inns there. There's no Wi-Fi. There's no coffee. It's a tough.
It's a tough life on Mars.
Life on Mars. Right. What else have we? We've got seasons. I suppose we want to. This is a good question.
Oh, yeah.
From Thaden Bois Primary School. Have I pronounced that right?
It's actually Thaden Boyce. That's very
Boyce.
new me.
Sorry, that's
Hello,
your neck
Thaden
of the
Boyce.
woods. I think this is a really interesting question, and I don't know the answer. Do you know the answer? How old is Mars? To the nearest year.
To the nearest month.
When's its birthday?
I think, and again, this is embarrassing because I have 2 degrees in this. It's been a long time. It is probably roughly the same age as Earth, so that's 4.1 billion years. I think it also depends on when you think a planet forms. Is it when it was first a little blob spiraling the sun, or is it when it kind of crystallized into what it is now, as opposed to being hot magma? But I would say it's probably similar age to the Earth, and if I'm wrong, I'm really, really sorry.
That's okay. You're allowed to be wrong. It's great. That is why we do degrees. We write things down so we don't have to remember them all the time.
Yeah, exactly.
Actually, and just thinking of kind of proto-Mars, a very young Mars, I think I'm right in saying it was a lot more like Earth. Earth and Mars were almost kind of twins in the way they developed. Is that right?
Yeah, that is right. That is right.
So it would have been warmer.
That's why we're
better.
so fascinated by why it doesn't look like Earth now. What happened to Mars? Will it happen to Earth?
May do tomorrow. What do we think? Is there a reason why kind of Mars kind of ground to a halt, if you see what I mean, at a certain point? Is it? I mean, I've heard lots of different ideas, like it's to do with its size. It didn't have the sort of internal core swirling around that created plate tectonics, etc.
Yeah, I mean that's one of it. Did it ever have plate tectonics? We have sent an instrument there to understand its seismology, so that's the kind of internal workings of it, to detect earthquakes. I think a lot of earthquakes are actually the result of asteroids hitting Mars. But yeah, why were there plate tectonics? If so, how did they and why did they stop? Did that cause the atmosphere to thin out? Did that cause the life to end? They're all really, really interesting questions that people are hoping to answer with these future missions.
This is why I love science so much, because there is no definitive end of science where we've answered everything, we can do something else now.
There's always more. Always more. Like, I think Mars quakes are just fascinating. Like, I want to learn so much more, and that InSight mission was so helpful in that. And we've got a question here from Ben L, who says, have you organised any missions for rovers or technology that have discovered huge discoveries?
Me personally, or the UK Space Agency?
Let's go for the
you
UK.
as a representative of ESA.
I think every rover we send and everything it discovers is a huge discovery, because we only get to send one of these rovers up maybe every 2 decades. So the chances, other chances to get this information, they're very few and far between. So every time we make a measurement of the Martian surface, even if it's just the dust or the atmospheric composition, is colossal. And I think it was the TGO, the Trace Gas Orbiter, the last ExoMars launch, that discovered methane fluxes in the atmosphere. So methane is a gas that's either created by volcanoes or by life. So finding methane on Mars, when we know there are no active volcanoes because there are no tectonics, is a huge discovery. So maybe that's the most exciting one in recent time. And we're excited to go back and see more about where that could have come from.
And I think we've got one more big question, which is, has any forms of life been discovered on the surface of Mars?
Not yet. Not yet.
Not yet.
We seem to get quite excited. I mean, I remember in the mid-90s, I think it was 1994, Bill Gates, who was Bill Clinton, who was the president of America at the time, in the Rose Garden of the White House, suddenly announcing, "We found a fossil meteorite," and there's a kind of fossilized worm in this meteorite, Martian meteorite that was found in Antarctica, Allen Hill's meteorite. And we all thought, wow, we found a fossilized worm, but it turned out not to be a worm. It's when we have strong emotions, we are liable to fool ourselves. Yeah. Seems to be especially when it comes to life on Mars.
And everyone wants to find life on Mars. I think
David Bowie did.
Yeah, obviously.
Yeah,
he loved it. He was all about that.
I mean, I think it's one of the biggest questions, isn't it? Are we alone in the universe or not? And so everyone wants to see this. It's why we're also kind of going further afield beyond Mars to places like Europa and Jupiter and Saturn's icy moons, which may also have a life. But,
yeah. Well, thank you so much, Natalya. It's been absolutely amazing chatting with you today. And thank you to everyone who sent in their questions. Do you know what time? It's almost time.
It's almost Mars hour. Yeah, thank you to ESA as well. And also thank you, ESA, for letting us borrow your spacecraft. You've lent us Mars Express for the day, and we're going to be patching into Mars Express for some live pictures of the Martian surface. Who knows? Maybe we'll find aliens.
I mean, who knows?
It's possible.